Welcome to the training module on the Multimedia Expansion Board DM320005. This training module will introduce the development board for multimedia applications and an overview of the Graphical library. Graphic displays are becoming very popular in an increasing range of human interface applications such as navigation, displays, point of sales, home automation, home appliances, medical, etc. All these are made possible by the significant price erosion in LCDs over the last few years. Today the prices of LCDs, either TFT or STN technology, are very affordable. Modern user interfaces provide several important benefits to human interface applications. They improve ease of use and create a rich user experience with visually pleasing images and touch. They add value and a cool factor to the design, and they enhance product quality and capability, making the end design more robust or suited for the environment it's used in. When it comes to graphical interface applications, most designers face several design decisions. The chart here shows some of the needs before starting a graphical interface. Designers need to pick the right LCD display. The common GUI features in the human interface applications include a scroll bar, checkbox, button, text support, picture or animation. Designers may also need to decide if the application requires a touchscreen support. The PIC32 provides a high-performance solution that meets the needs of today's increasingly more complex, highly interactive user interfaces. Built with a 32-bit core running at 80 MHz, PIC32's processing power, coupled with the high-speed 16-bit PMP, vivid 24-bit color WVGA displays can be driven with ease. Additionally, the PIC32 MX 5, 6, and 7 series offers up to 128 KB of SRAM and 10/100 Ethernet and CAN controllers to add remote interface capability to your design. This page shows block diagrams of the Multimedia Expansion Board. The snapshot of the DM320005 is shown here. It consists of a Solomon SysTech graphics controller SSD 1926, a microSD card slot, a regulated 3.3 volt and 1.8 volt power supply for powering the board via a starter kit or 9 to 14 volt power supply. It also has an accelerometer and temperature sensor, BMA150, and a 24LC08 EEPROM, a 2 MB SPI flash, which is an SST25V F016, a 24-bit stereo audio codec, which is a WM8731, a CPLD for SPI, and chip select configuration, PIC32 starter kit connector, and integrated 802.11 wireless connectivity. The Multimedia Expansion Board is an integrated yet flexible solution for development of high-impact user interfaces. The board comes with a 3.2-inch color TFT touchscreen display and interfaces to any PIC32 starter kit, allowing you to choose the device family that works best for you. Many industrial and consumer applications have a need for remote control of the application. The Multimedia Expansion Board comes with an onboard FCC certified Wi-Fi module and can accommodate the general purpose Ethernet and USB PIC32 starter kits. Other features include a 24-bit stereo audio codec, 3-axis accelerometer, a joystick, and a microSD memory slot card. This page gives information regarding hardware content of the board. It consists of a DC power supply jack, which can accept 9 to 14 volt DC, a starter kit connector where any PIC32 starter kit can be used in conjunction with a multimedia expansion board through the PIC32 expansion connector, display, microSD card slot, joystick and fire button, and LEDs, accelerometer, and a temperature sensor. The Multimedia expansion board has a 3.2-inch QVGA TFT touchscreen as shown in this page. The display is controlled by a Solomon Systech SSD1926 LCD controller. The display controller may be configured to use an 8-bit or 16-bit interface. The display also has a resistive touchscreen and backlight controls. The Solomon Systech SSD1926 graphics controller provides a 4-wire SD card interface. The Multimedia expansion board takes advantage of this interface by providing a microSD card slot. The Multimedia expansion board provides 2 different onboard storage mediums, an EEPROM, a 24LC08, and a serial NOR flash, an SST25VF016. The 24LC08 is a 128-byte EEPROM. The PIC32 microcontroller uses an I2 bus interface to communicate to the 24LC08. The SST25VF016 is a 2 megabyte NOR flash. The PIC32 microcontroller uses an SPI bus interface to communicate to the SST25VF016. The CPLD needs to be properly configured for the PIC32 microcontroller to be able to access the SST25VF016. The Multimedia expansion board can run applications that require audio playback and/or recording for playing back audio. The Multimedia expansion board provides 2 output jacks, a headphone and a line-out jack A. Microphone input jack is also provided for audio recording. The WM8731 interfaces to the PIC32 microcontroller via the SPI and I2C buses. Microchip offers a licensed graphics library. The library provides ready-made codes to render graphic objects, fonts, and languages. It has an optimized user interface to support various buttons and keys for M-Touch sensing and is compatible across 16 or 32-bit PIC MCUs. Microchip also offers the licensed Graphics Display Designer. This is a visual design tool with a GUI design wizard for designing graphical user interface GUI screens. This tool works together with the graphics library and allows developers to design screens at the application level without coding. These free tool suites help developers reduce the overall development time and improve product time to market. The Microchip graphics library was created to cover a broad range of display device controllers. Targeted for use with the PIC microcontrollers, it offers an application programming interface that performs rendering of primitive graphic objects as well as advanced widget-like objects. The library also facilitates easy integration of input devices through a messaging interface. Applications created using the library will also find a simple and straightforward process to change display devices if the need arises. The layered architectural design of the library makes all of this possible. The Multimedia expansion board has 802.11 wireless connectivity, which is provided by Microchip's MRF24WB OMA module. The PIC32 microcontroller uses an SPI bus interface to communicate to the MRF24W VOMA. The CPLD needs to be properly configured for the PIC32 microcontroller to access the MRF24WB OMA. Microchip's family of economical hardware debuggers are the perfect choice for developing and debugging designs based on the Microchip PIC and DS PIC products. MPLAB RealICE, MPLAB ICD3, and MPLAB PicKit. 3. Offer in-circuit debugging and programming with simple interconnects to the target system. MPLAB ICE 2000 provides legacy in-circuit emulation for many Microchip PIC devices. MPLAB RealICE delivers the most performance and fullest support. This page gives details about the features and facilities of the debugging tools like the PicKit 2, MPLAB ICD2, PicKit 3, MPLAB ICD3, and MPLAB RealICE.